So this Markowitz model is like, we also say like it is a method to find like the like our optimal portfolio we need to find, correct? This is a method to find an optimal portfolio. So what is an optimal portfolio? Like given like you have some assets like asset A, asset B, asset C, etc. You have given multiple assets, and each asset comes with like some expected return. Okay, it has some expected return, and it has some variability like the standard deviation of its return. Similarly, like this will be ERAs. So you, if you are given this information, and then your objective is to find the optimal portfolio according to your risk appetite, correct? So if you are a rational investor, what would you like? Like you would like to have more of expected return, like you want more return and less of risk. And risk we generally like we, like we represent risk through the variability in your returns. Like the more variability, it is deemed to be more risky the asset is, correct? So we want to maximize this and minimize this, correct? So this is the basic concept behind like finding the like the basic concept behind the Markowitz model. Okay, so let's take an example and then we will see like how this model works. Let me just, so I will take an example from your lecture notes only. Okay, let me just go through the notes. So suppose there are two types of assets. First, like we take it to asset example, and then so in the lectures you have noted like the first what is the process that is followed in this Markowitz model is like first you find the optimal risky portfolio, correct? And then you incorporate the risk-free asset or the fixed as like the risk-free asset in that, and you find then your optimal portfolio, correct? So what, first let me just like the summarize the process. So first what you are given, like you have like let's suppose these all are risky assets. Risky asset is like whose return is not fixed, like there is some risk involved in the assets return, correct? So you may have like multiple risky assets, okay? So there may be abcd up to like there are many, like there are many stocks, many bonds there are in the market. So you have a lot of risky assets available to you, and you can like the opt any one of them. So given those risky assets, so what you can do, you can represent all your risky assets in a like the risk return diagram where your expected return is given in the vertical axis and standard deviation is given in this horizontal axis. So you can represent your assets. So for example, if you represent your like this is, let's suppose this is asset A, this is asset B, this is asset C, and so and so forth, like there are multiple assets there. So what you will find, like you will find then like all these risky assets, you can find a leftmost boundary, like the all these assets are here. Then let's suppose this. So okay, so you can create a boundary around these all risky assets which are available to you. Okay, and on these and these risky assets, this leftmost boundary, what we call this the minimum variance set. Why minimum variance set? Because like the given any, so let me take an example. So given any expected return, so you want minimum standard deviation, or I am saying variance. So like variance is the square of your standard deviation only. So given any expected return, so let's suppose I am taking R1 bar or R2 bar. So if you are a rational investor, what would you like? So let's suppose you fix your expected return. So you fix your expected return. So you want to pick the combination of assets which give you the minimum variability. So you will stop here only, correct? Similarly, like if you are choosing R2 bar, then you will stop here because this is the this is the combination of assets which you will choose, because this gives you the minimum variability. So the the combination of assets which is like the intuitively, like the which I should consider for investing, are the ones which are on this leftmost boundary of all the available assets combination, correct? So these, like you can create as many points, and like these points are created by combining the, let's suppose these three assets are available to you, then by combining them in different compositions you can create like various portfolio, and I have represented those various portfolio by these dots. And like the you will, like the combination, like the portfolio which appears on the leftmost boundary is the one which I should consider if I am a rational investor. Why? Because you want to you want minimum variability for a given expected return, correct? So you got this purple line is, this is your minimum variance set. Okay, now our, like the first part is done, so we got the minimum variance set. Okay, if I have these three assets available to me, and I try different combinations of them, like the different, I allocate different amount of my wealth to these assets, and I create these different portfolios, and I find that this the leftmost boundary is the one which I should consider for investing. Okay, now can I also minimize, like the can I also modify this further also? Okay, so let's consider like, so now I have got this the minimum variance set. Now second thing is, okay, so now let's suppose I choose a given variability. Let's suppose sigma 1, sigma 2. So if I draw a vertical line, then in this minimum variance set, there are two possible, like the portfolios, or two possible combinations of these assets. One is this, the bottom one, and second is the upper one. Correct? So which one will you choose? So like your variability or your risk is fixed. Like if you choose your risk level to be sigma 1, then out of these two portfolios, like this, I would say X1 and X2, which one will you choose? You will choose X1 because it gives you higher expected return, and X2 gives you lower expected return, and your risk level is the same. So these are the points. So the points which appear on this upper part. So if I take, like you can find this leftmost point also here. Suppose. So you, the leftmost point on this minimum variance set, like this point, this is the point which we call the global minimum variance portfolio. Why? Because this is the portfolio which gives you the minimum variance possible. Correct? So given this, like there is no other portfolio which gives you the variance which is lower than this. So the this leftmost point on this minimum variance set is called the global minimum variance portfolio, and all the points which are above this global minimum variance portfolio are part of your, like are the portfolios which you should be considering for your investment purposes. So let me denote it by, let's suppose, which color, okay, this green color I am. So this part, like the all the points which are part of minimum variance set and which are above this global minimum variance portfolio, they form like the set of portfolios which you should consider for your investment purposes, and we call that efficient frontier. Okay, so this we have done for, like if I have only the risky assets which are available to me, correct? So for risky assets, like there will be, there is some expected return, there is some risk involved in the form of like the standard deviation of your returns. So from that combinations, you are able to find your efficient frontier. So this is the first step of Markowitz model. Next, what? So from this, like once you got your efficient frontier, so let me draw another diagram. So far what we have done is like, so we have found our efficient frontier given this. So one thing that is sure is like I want to choose a combination of risky portfolios from this efficient frontier only. Now which one to choose? Like what is my optimal risky portfolio? For that, what we do? So how do you find your optimal risky portfolio? So for that, what you do, like you want to maximize your returns given like the in proportion to your risk level, and that is represented by what we call as Sharpe ratio. Correct? So for that, what we need to do, you need to maximize Sharpe ratio, and Sharpe ratio is nothing but expected return, like the expected risk premium upon your variability. So how do we do that? So in the class, I think you would remember, like you have derived the capital allocation line, which has the slope of Sharpe ratio, correct? So you can represent your capital allocation line and whose slope is the Sharpe ratio. So you want to like the you want the this you want to choose the capital allocation line, like you want to choose a portfolio from this. So there may be multiple capital allocation line, like there may be multiple Sharpe ratios possible, which are represented by the slope of these capital allocation lines. So you want to maximize the slope, but you want to choose one from your efficient frontier. So one that would maximize the Sharpe ratio would be the one which is just tangent to your efficient frontier. So the one like where your this capital allocation line, which is just tangent to the efficient frontier, and the point at which it touches your efficient frontier would give you your optimal risky portfolio. Why risky portfolio? Because till now we have not considered the risk-free asset in our case, because risk-free asset in this return risk diagram is represented by this point, like this point where like the return is RF and your risk or the sigma is 0 at this point. So this is the point which represent your risk-free asset, correct? So from this exercise, like this is the process through which you can get your optimal risky portfolio. And and one thing you should notice, like in this process of finding the optimal risky portfolio, we have not considered any of the features which are specific to a particular investor. So there is no role of like the how risk averse is the investor, etc., etc. We have not considered that. So this optimal risky portfolio is same for all the investors who are considering, like the, for example, we have considered three risk assets ABC. So all the investors who are considering portfolio combinations from these three assets, they would choose like the same optimal risky portfolio is same for all the investors. Okay, so once we got this, now what an investor would do, an investor like now investors choice would break down to only a simple case where there is one asset, one risk free asset and one risky asset. These two assets are there available to him, and he would like to choose the one which gives him the maximum utility. And these utilities are represent incorporate the risk averseness of the investors. This is where your risk aversion coefficient will come into the picture. So if the investor is more risk averse, it is less risk averse, and that will determine his indifference curve. And what would be the shape of indifference curve in this like the mean variance diagram? So mm, okay, so suppose like you are an investor and you want to draw a indifference curve. What is an indifference curve? Like the curve which like the combination of points which gives you the same level of utility. So suppose currently you are at this point. So if your utility will increase, if your expected return increases, and utility will decrease if your standard deviation or the variability or what we call the risk decreases, correct? So if it increases, then it should also increase. So both of this point will be the part of your indifference curve. And if your like the expected return decreases, then your risk should also decrease in order to give you the same level of utility. So in that way, like your indifference curve in this risk return diagram are the upward sloping. So this would be the shape of your indifference curve. Now, to find your optimal portfolio, what you would do, like this is for a given risk aversion level. So if you are given this indifference curve and you have this optimal risky portfolio, then you can draw your capital allocation line and you would impose this indifference curve on this, and then the point at which like these two are tangent to each other, like this capital allocation line for optimal risky portfolio and your indifference curves, wherever they are tangent to each other, that would be your optimal portfolio which you should choose. Okay, so that exercise would give you, so if you impose it, let's suppose it like that, it is tangent at this point, so this will be your optimal portfolio. So this is the process, like this is the main working behind the Markowitz model. And in numerical terms, what we do, like in numerical terms, so in Markowitz model, if you are given like the two or three or multiple assets, so let's suppose we take the two assets example. So asset A and B with RA and sigma A and RB and sigma B, and there is a risk-free asset with RF. Okay, this is risk-free. So in this process, what you would do? So first, like, so there may be multiple things you may be asked to you. So first, like if you are asked to like to find global minimum variance portfolio. Okay, so global minimum variance portfolio, which is like from the combination of these two assets. So if these two risk assets are given to you, then the question asks you to find the global minimum variance portfolio. Okay, so how you would proceed with this? So in a two assets case, so let's suppose you assign weight to asset A to be WA, and you the remaining of your wealth you invest in your other asset. So you are investing in only two assets, as like we are working with only risky assets, so remaining wealth goes to risky asset. Okay, so this is for asset A and this is for asset B, and we can call this WB also. So if these two are the weights given for your portfolio, then using the portfolio variance formula, so what will be the portfolio's variance? And let's suppose the correlation is given to be like the covariance is given to be sigma AB. Okay, so if this is given to you, then your portfolio variance would be correct. So if you are asked to find the global minimum variance portfolio, okay, then your objective would be to minimize this thing, like the minimize this one, subject to like the what would be the condition is only this, like your weight should sum to 1, or you can directly you can directly incorporate by replacing WB to be 1 minus WA, and you just need to minimize this with respect to like WA or WB. And if you like the replace this equation in your objective function, then it will be only subject to WA only. And by doing this, like you can find the global minimum variance portfolio. Like by doing this minimization problem, you will be able to find the weight like the WA and WB, and these weights define your portfolio. Like this much amount of wealth should be invested in asset A and in asset B, and form your that would form your optimal, like that would form your global minimum variance portfolio. Okay, so
So do we need to know the steps to find W star A and W star B, differentiate and find out?
so
Is this
so
important?
so you should know the process, but I think in the class, like the formula is also given by the professor. So knowing that
Okay.
would also suffice, but knowing the process is a good thing, because if like some, like the tweaking in the question is done, like if like there are multiple assets are there, so
Okay.
and so if you know the process, then instead of two assets, if this is given for like there are four assets A B C D, then also you can do this like this minimization problem if you know the process, and you can find four
Yeah,
different
that
weights.
yes, sir. That we can do with but so in the but for the exam, the row value will be given, right? The covariance.
Yes,
Okay,
like
all right.
either
We do
this either this covariance or the correlation value will be given to you.
okay, all right.
Yes,
Thank you.
and you know the relation between these two things. I think this is simply the,
Yes, sir.
yeah.
That's
So
there in the slide. This part is there in the slide very clearly. So
yes, so knowing the process is the, like if you are stuck somewhere, so let's suppose the question is given in a different form. So let's suppose if you are given the portfolio variance and weights and this thing, and you are given to find this one, then how do you go about this, etc., etc. So
okay,
if
okay,
if you know the process, then you can solve all type of questions are there.
right,
Correct.
okay,
And
right, sir.
another type of questions can be asked like, so you are given this like the returns, so is it asked like what weights you should give to this, you should give
So
to.
the GAs, yeah, the GAs have these questions, but the deadline is not passed, so we can't discuss. Mm.
So I am not using like, that's why I am only just using the notations, not any calculative questions here. So
Okay.
yeah.
So in the quiz, they've asked what will be the weights of W star A and W star B,
Yes.
right? So that has come in the quiz also.
Yes, I think those type of questions will like those were part of previous term questions, and those will be in this term's questions also. Like in
Okay.
the second quiz
Okay.
part will be there.
Okay, sir. Thank you.
So you should give to like the to get an expected return of, let's say, R bar. So let's suppose you are given like the RA to be some 10%, RB to be 18%, and you are supposed to find a portfolio which gives you an expected return of, let's suppose, 15%. Then what are the weights you should give to these two assets? So this is a very, so you should not
Right.
complicate yourself, and like you should know the formula for the expected return of a portfolio. So if you are given a, so expected return of a portfolio will be,
So that will be W A star with the expected value at RA with
yes,
returns of A and plus the 1 minus
correct. So
W
this
A star
W, there are only two assets, so this will be equal to 1
right,
minus WA star. So let's suppose
into
if we
expected of B.
yes,
Expected.
they yeah. So if I replace these values, so this should be 15% should be equal to WA star
Mm-hmm.
times 10% plus
10.
1 minus WA star
Mm-hmm.
times 18%.
18%.
So
Right.
you can simply solve this equation and you can find WA
Easy.
star and you will find the value. Correct. So this
Okay.
is the another type of questions maybe asked, and like you now you know the formula for calculating the portfolio variance and portfolio return, expected return of the portfolio given the
Mm-hmm.
weights, and from the Markowitz model you can find like the weights for the global minimum variance portfolio, and also like if you are to find the optimal risky portfolio, for that your objective would be to like the maximize, Sharp ratio. And Sharp ratio is your expected return from your portfolio. So that is like we replace it by this formula minus the risk-free return divided by the portfolio variance.
Yes,
So,
standard deviation. Yeah.
correct. And like this becomes a very complicated maximization problem subject to
Mm-hmm.
your WAWB, correct? So the process is given in the slides. So like this is a very complicated, so I think some theoretical questions may be asked on this because this takes a lot of time to solve this type of maximization problem. So in exams, like we try to avoid such lengthy calculative questions. So some
Okay.
theoretical questions on this, like you should know the concept, like how you find the optimal risky portfolio, like you should know the concept, like you need to maximize the Sharp ratio,
Mm-hmm.
not only like minimizing the variance would not suffice. You need to maximize the Sharp ratio to find the optimal risky portfolio, and you should also know the whole process of the Markowitz model. And we know like it is a very lengthy process, so in GA I think we have one or two questions on this topic, like because in GA
Yes,
you can solve at your home, like you can devote some extra time. There is no time bound there as such. So that's why we have some questions for your practice. But in exams, we try to avoid like the finding the optimal risk, like the maximizing Sharp ratio type of problems there. Okay, but
understood,
you
sir.
should know, you should be aware about the process, like what are the different steps, like what are the different steps of your Markowitz model. So first, like you find the minimum variance set. From minimum variance set, you deduce to your efficient frontier. Then on efficient frontier, you find the optimal risky portfolio by like finding the
The
point
capital
where CL is
CL, right?
your tangent.
Yes, sir. Capital, right. Right.
And then from this optimal risky portfolio and risk-free asset, you find your optimal portfolio according to your like the utility functions, or what we say, like which are determined by your risk aversion coefficients. Correct?
Right. Yes, sir. So CAL is important, right? Capital asset, that allocation line, that is
Yes,
important.
yes, that is
How it
important.
works with the maximizing of the Sharp ratio.
Correct.
Okay. Got it, sir. Thank you. So I do have one question about the front. You said that the minimum variance frontier.
Yeah, minimum variance set and efficient
Sorry.
frontier.
Right. Shouldn't the line be the variance line, variance frontier, and the set should be the points inside?
No,
The
like
set
if
will be
you no no
enclosed by
why
or
we call
the
this a
minimum
set, because this line represents like the multiple portfolios, like each point on
yes,
this
sir.
line. Okay, sorry, let me present it again.
I think the line should be called the minimum variance frontier. The top part is the efficient frontier. And all the points bounded by the minimum variance frontier should be the minimum variance set. And then the viable set, the optimal viable set would be all in the above the global minimum.
No, like this is
No,
the
like
no,
this is
we
the
are not the
we
one
are
who
not the one who.
So you have two mics on.
sorry. So we are, this is the terminology which is like the used in finance literature. So that's why we are adopting. And why this is called a set, because on that leftmost boundary which you are saying a line, so they like consist of multiple portfolios. So it is a set of portfolio. That's why this name is derived from there. Like this is the set of portfolios which, like for a given expected return, this is the set of portfolio which have the minimum variance for a given expected return. That's why we call, like this is a set of portfolio with minimum variance. So that's why we call the minimum variance set.
Okay, okay. Because in the textbook, so I'm just following the textbook, sir. So from the beginning,
Hmm.
in the textbook diagram, the actual points of the portfolio within the frontier are all minimum variance sets, and then the frontier is called the minimum variance frontier. That is the line bounding on the left side of the set. That is
Okay, so
the
in the book you of the
Ivo.
Ivo Wells book, correct? So
Ivo. Yes.
so I will check with the like the professor
And
if
that's okay.
it is.
Yes, sir. Right. So it says that the top part of the frontier is called the efficiency frontier,
Yes,
and that also has got subdivisions, right? So now the whole new papers on this efficiency portfolio also.
yes, yes.
Okay,
So
it's good.
yeah. So is there any so in the next week what we would do, like we will the type of revision session we did for the quiz one, we will do the same again for the upcoming quiz. I think that is next week, I think, correct?
Yes, sir.
Yeah. So in the next week's session, what we would do, like we will do a revision session for our second quiz. Like we will cover from week 5 to week 8, and these 4 weeks will be the part of your second quiz. And I would
Okay.
try to cover like all the topics like as far as possible. And I know like I missed previous week's live session, so I would try to like get some time and record one extra session in which like I will try to cover both week 7 and 8 and try to like to cover all the topics. I know I could not complete all the topics in the week 8 also, so I will try to do that thing in the meantime.
Well, fair enough, sir. If you share that, then we'll use that to study for the quiz too.
Correct, correct. And in the next week, like you do your your study, your revision, and you come up with your questions, and I would be happy to like answer your doubts. And also, I will try to solve like through some examples. I would try to recap all the topics which were covered in last 4 weeks.
Understood, sir. So I do have two questions. Actually, one is a question that will the pattern be the same? Can we use the PYQs to practice?
Yes, like the pattern would be the same, like all MCQs, and like the type of questions will be same, like the and
Similar.
the
Okay.
syllabus will be last 4 weeks.
So in the previous terms, there were one or two questions from weeks 1 to 4 also.
I don't think that is the case, and the thing is like you find it that way because like the concepts which we
There's some
learned,
overlap. Yeah,
yeah,
there's
some
overlap.
overlap is there. That's why you like the you
Okay.
think it is the case, but
Right.
mostly it will be from last 4 weeks only.
Yes, sir. So I was asking about the pattern because I personally am facing a problem trying to remember and recall which formula or which concept to apply based on the wording of the question. Right. So should I take the absolute value or the expected value or the future value? Sometimes it's not clear for me. Right. So
So
if I can follow the, yeah, sir.
I think like the this should be clear from the question itself. Like so so can you give me an
I
example like where you find it?
Yes, I'm seeing, see, I'm looking from investing in the real world and I try to apply that to solve these, right?
Hmm.
So sometimes I'm not sure. Okay. So if I follow the pattern of the GA and the PYQ, like,
Hmm.
okay, if you ask this question, it means this only,
Hmm.
is it okay if I stick to that?
Yes, yes, like the sticking to GH and PYQ, like that is because we try to adhere to the same type of pattern in the exams because most of the students practice from those only. Like the
Okay.
slides,
Okay.
GH, and the PYQs, like you should cover these things, and this would be enough for your exam preparation.
Wonderful, sir. Yes, sir. Okay. Thank you, sir. Good session today.
Yeah. So did I cover your doubts related to Markowitz model, Yoganandam? So if you have any
I
other
think
queries,
Lalu Prashant asked. Okay, it was. fine. I think we'll have to practice more for
Yes, yes.
this thing.
Can I
Okay,
ask one more
great.
question? These practice questions that you share, they don't have
Yes.
any points. There's not any bonus marks or any extra credit, do they?
No, no, no. Those do not have any.
Not in corporate finance. Okay.
No.
All right, sir. Thank you so much. I'll see you next week.
Sure, sure. We will meet next week and we will do a thorough review for last 4 weeks. Okay.
All right,
Thank
sir.
you.
Thank you,
Thank
sir.
you.
Bye. Bye, Yogananda.
Thank you. Bye. Bye. Thank you.